So this week, in week 6, we're going to finish up dosage calculations, which takes us all the way to the end of chapter 31. So your reading this week should be from 886 through the end of the chapter, which I believe ends on 892. So about 5 more pages. So let's talk about first rounding equations. There will be some occasions where it's necessary to round your answers in order to obtain a correct dose or a measurable dose. Some people prefer to use the proportional method when calculating dosages. Well, let's talk about rounding for one more minute. So you want to round to the nearest tenth when giving more than 1 ml. You want to round to the nearest hundredth, which is the second spot behind the decimal point, when giving less than 1 ml. For 1 to 4, we round down. For 5 to 9, we round up. Table 31-7 can help you with that concept. So for example, if I have a dose that's 51.44 mLs, I'm going to round down to 51.4 mLs because the second number there is 4, and we round down when it's 1 to 4. When there are tablets, we round to the nearest whole number of what is available. If you have a pill cutter or if the tablet is scored, you can round to the nearest half tablet. Again, table 31-7. So moving on to calculations. The proportional method, which I believe is the method I use. I'm going to stick to that one. It's, for some reason, the second method, the formula method, isn't one that I really enjoy teaching, using, or feel that it's very helpful. So proportions are just like you learned in high school math. You set up an equation and you're solving for x. So step 1, determine if ordered dose is in the same units as dose on hand. If not, this is where the first part of this chapter comes in. We convert to the 2 so that the 2 are in the same units before calculating the dosage. Step 2, set up that proportion or fraction to calculate the dosage. Remember that the proportion is the same as a fraction. Step 4, cross-multiply the numbers. Multiply the numerator from left fraction with the denominator of the right fraction and vice versa. So the top of the first fraction, bottom of the second fraction, you're going to multiply those, come up with an answer. And then the bottom of the first fraction and the top of the second fraction, you're going to multiply those and come up with an answer. And then you're going to solve for x. To check whether your answer is correct, insert answer into original formula in place of x and cross-multiply. The two should equal each other. So the example they lead you through is the physician orders 0.75 grams of Luvox. The medication on hand is 500 milligram tablets. So we can see right away that our units are not the same, so we need to convert. In order to go from grams to milligrams, we know we could use that chart, and it'll tell us to move the decimal point 3 places. So if we go move the decimal point behind the 7, move it behind the 5, and then move it 1 more over and add a 0, that'll give us 750 milligrams. Or you can do the equation that they have set up there. Our second step is going to be set up a proportion to calculate the dosage. 500 milligrams over 1 tablet, so 500 milligrams per 1 tablet is equal to 750 milligrams for how many tablets? And how many tablets is our x? We're then going to cross multiply the numbers. So we're going to multiply the 500 by x and 750 by 1. So now you have 500x equals 750. So you're going to solve for x. So to get x alone, you'll need to divide the left side of the equation by 500 and also the right to cancel it out. So 500 over 500 equals 1. So you have x by itself. And the other side is 750 over 500, which is equal to 1.5. So the answer is going to be 1.5 tablets. The formula method, I'm going to let you guys go over that yourself. I really recommend the proportion method. It's just a little easier than figuring out desired dose, on-hand dose, etc. They both work, depending on how you feel about them, they both work as well as the next one. Just get comfortable with one method and get used to using that method to do all of your dosage calculations. So calculating pediatric dosages usually goes by either weight or body surface area. Pediatrics are not just tiny humans that get slightly smaller proportional doses. Their immune systems aren't that developed, their metabolism and excretion systems aren't as well developed as an adult would be. So when you calculate pediatric doses, you need to look up what your dose is based on what the manufacturer or drug studies recommend. So calculating pediatric dosage by body surface area. The body surface area is the most accurate method of calculating drug dosages for infants and children up to 12 years of age. In order to use this method, a child's height and weight must be known. A nomogram is a graph that illustrates the relationship between two known values. The BSA is figured by drawing a straight line from the patient's height to the patient's weight, and where the number intersects on the surface area line is the figure that is used for the BSA. So you use the BSA of the child in meters squared, divide it by 1.7, multiply that number by the adult dose, and that should give you the child's dose. So, by kilogram of body weight is what you see used a lot in clinical medicine. So you're going to convert your pounds of the child into kilograms and multiply the dose ordered by kilogram of body weight. For example, amoxicillin for ear infections is ordered 90 milligrams per kilogram. So if you have a 10 kilogram child, they're going to get 900 milligrams of amoxicillin, most likely split into 2 doses, but that's how much they're going to get for the total day. Okay, so and if applicable, divide child's dose by number of equal doses to be given in a 24-hour period. So that amoxicillin that we just talked about, that was 900 milligrams, let's say we want to give it Q12 hours. There's 24 hours in a day, so every 12 hours is going to happen twice in a day. So that 900 would be divided by 2, so one dose is 450 milligrams, and the second dose of the day is 450 milligrams. So a little bit about insulin. Insulin is a high alert med, and it's complicated. So insulin is measured in units and should be administered with a syringe that also measures units. Usually insulin is given less than 100 units at a time. So you have a U100 syringe that will measure up to 100 units. There are 100 units in 1 milliliter or cubic centimeter of medication. Never use a standard syringe when administering insulin. The doctor is going to tell you exactly how many units to use, and you'll use that special insulin syringe. Errors in dosages can lead to serious complications or even death. So you just want to be really careful that you're not overdosing the patient or even underdosing them. When mixing insulin, make sure the two are compatible, because not all of them are. You can mix some of them in the same syringe. And you want to make sure you start with the clear and then draw up your cloudy insulin. So types of insulin. Types of human insulin specifically. Regular, short-acting, it starts working in 30 to 60 minutes after administration and lasts 3 to 6 hours. Intermediate acting starts working 2 to 4 hours after administration, and it lasts 10 to 16 hours. Premixed is a mixture of both, so you get a little bit of short-acting and a little bit of long-acting to balance it out. Analog insulin medicines. So rapid-acting insulin. It's very quick and taken shortly before or after meals. Whereas long-acting insulin takes the longest to exert its effects, and it lasts 4 to 24 hours. It kind of provides a stable, all-day-long sort of control of blood sugar. Premixed, both intermediate and fast-acting effects, manufactured in different combinations, and tailored to sort of what the patient responds best to. So reading medication labels. The medication label is the product label that gives vital information about the medication. Medications normally come with an insert that has additional information that can be really helpful. So that picture there, that pretty little picture. So let's start at the top left. Description of tamper-resistant feature. So for example, do not use if seal is missing. Next down is the product name or statement of identity. So next, somewhere on that bottle should be a listing of active ingredients, a list of inactive ingredients, and exactly how much total is in there. So in this case, 12 fluid ounces or 355 mLs. There should also be the name and address of the manufacturer, packer, or distributor. Somewhere on the bottle, probably on the reverse, you'll find an indication for use. Any special instructions, any warning or cautionary statements, drug interaction precautions, such as do not take this product if you're presently taking a prescription antibiotic containing any form of tetracycline, an expiration and lot or batch code that the manufacturer has put on the bottle. Those all should be present in each bottle or package somewhere on the box or in a fold-out. Sorry about that, guys. Just trying to get the dogs to calm down for a hot minute. Okay, so prescription labels consist of a product name, and this is the label that the Walgreens or CVS or hospital pharmacy slaps on a bottle. This should consist of the product name, the generic name, the national drug code or NDC number if needed, the dosage strength, drug form, number of units or total volume, usual dosage and frequency, route of administration. Actually, this is not the, please hold. When they say prescription label, normally what I'm thinking of possibly has, okay. So they're talking about a medication that it comes in a bottle from the manufacturer. So for example, that Vistara label that you see at the top right of page 891. I thought they were talking about the one that you might get on a bottle that you get from CVS or Walgreens. So prescription medication labels are a little different than non-prescription labels. They include, again, product name, generic name, national drug code or NDC. It's an 11-digit number that can identify the drug. Dosage strength, drug form, number of units or total volume, usual dose and frequency, route of administration, manufacturer's name, and again, that expiration and lot number. We're just going to talk over the dogs tonight. When you're reading a medication label, warning labels, and this is more, again, on the bottle that you might get from CVS or Walgreens, those little amber vials. Warning labels are placed on medications indicating special instructions for proper and effective usage of the drug. They inform patients of side effects, may instruct them on how and when to take the medication, as well as what to do with the medication as far as storage. So the ones you see in figure 31-5, ones we use commonly are refrigerate and shake well, do not take dairy products, do not drink alcoholic beverages. These are all pretty common medication labels or like warning labels. So that gets us through the rest of chapter 31. I'm very sorry for my rude dogs who have been barking. I hope everything was clearly understandable and that you were able to hear. This is moving on to our last lecture in week 7 before we have the final in week 8. As always, email me with any questions, and I'll see you guys in week 7.